Okay, so when you have your no solution, those are pretty easy to pick out because you're going to get down to that false statement like we talked about on a previous video. So you'll get like 0 equals 10 or something like that. But when you have your infinite solutions, it can be a little tricky to figure out. So let's talk about this problem here together. And I'm actually going to come down here where I have a little room. You may want to go to some extra paper. And if you'll notice that your first equation has two variables, it has a y and a z. Your second equation has two variables, but it's different. It's x and y. And then your third variable obviously has three variables, x, y, and z. So remember, the idea here is to try to get to what we call like a 2-by-2 system. So let's say I take equation B, okay, equation B, let me rewrite that. So that's 2x plus 3y, I'll leave a little blank where the z would be, equals 2. And I pair that with equation C. Okay, and then remember, you have to think ahead here. Equation A, remember if you look back up here, it just has a y and a z. So if I eliminate my x's, okay, my x variables, then I will have another equation that has y's and z's that I can use with my equation A. So I want to eliminate my x's, so I'm going to take equation C and multiply it by 2 so that my x variables will eliminate. All right, and so you cancel out your x's, you're going to get a negative y plus 2z equals 0, and this will be our equation D. All right, and then remember, you're trying to figure out how to solve that 2-by-2. So you want to go back to equation A, and you're going to pair that with your equation D. And this is one of those that as you write this step out, you're going to go, oh goodness, this is one of those weird ones, because the y's eliminate, the z's eliminate, and you get the 0 equals 0. So this is that infinite solutions. So remember, we want to write the complete solution here, okay, as we were doing in our 2-by-2s. And so you want to write everything in terms of z, and you can see they're talking about that up here. You're going to have your x in terms of z, your y in terms of z, and then you'll just have a z. So your solution is going to look something like this, comma, comma, z, okay, where what's in the x spot is some algebraic expression in terms of z, and what's in the y spot is an algebraic expression in terms of z. And so you just have to figure out what goes there, okay? So like if you take your equation A, I have y minus 2z equals 0. So if I solve this for y, I get y equals 2z, and that's a replacement for my y. And remember, it has to be in terms of z, so that works. So I can put in a 2z there. And then you've got to figure out a replacement for your x, okay? So let's say you choose equation B, and there's lots of different ways to do this, by the way. So if you've got a different way and you want to talk with me about it, that's fine. And so I'm going to put 2x plus 3y equals 2. But see, I know that my y can be written as 2z. All right, and so then I solve this for x. So let's see if I can squeeze this in here. That's going to be a 6z, and I'm going to subtract that over. So it'll be minus 6z plus 2. And then divide out the 2. Come down here a little bit. So you're going to get x equals negative 3z plus 1. And that's what you can put into your x spot. So you just have to find some representation of x in terms of z and some representation of y in terms of z. All right, and then you could generate solutions picking a z value, right? So let's say you pick a z value of 10. That means your y value will be 2 times 10 will be 20, and your x value will be negative 3 times 10 plus 1. So what's that? Negative 29. And that would be a solution of this system. Okay, and then you could pick a different z value, which gives you a different y, a different x, and so forth, and you can do that infinitely. But like I said, we are going to express our solutions in this complete form. All right, if you have questions, post them in the discussion board, and I'll see you in the next video.